Hello everyone, my name is Neil Gibson. Thank you very much for joining us today for our webinar. Today we're joined with our friends from MagiCAD, and this webinar is going to demonstrate the interoperability, meaning the connection between the virtual environment and MagiCAD. So bringing together the analysis of the virtual environment together with the design capabilities of MagiCAD. The demonstration is going to specifically show we're going to be importing an architectural model from Revit into the virtual environment. We're then going to run our analysis within the virtual environment for our SIBC loads. Of course, it's the same process if you were going to be running AshRay. Once we've got that, we're then going to export from the virtual environment using this new interoperability connection into MagiCAD, where you'll be able to then see we're going to develop our coordinated MEP design within MagiCAD itself. If you use the virtual environment, it might be the case that you use the virtual environment and you feed your analysis into your mechanical colleagues in their design teams for their projects. But of course, this webinar today is equally as interesting for your mechanical colleagues as well. So you as a champion with the virtual environment, you might be, you'll be very used to the breadth of building performance analysis within the VE, but let's not forget that at the very core of IESVE virtual environment, it's a robust engineering tool. And today we're going to be showing just how easy it is to run your loads there and use MagiCAD for your design. Another quick note on interoperability. This is not a new thing for the virtual environments. In fact, actually, we've got a long history at IES of being open, whether it's through partners like One-Click LCA or JPA, or maybe through our exchange formats like GBXML and IFC, and being able to connect to a whole range of packages like Revit, SketchUp, and Rhino. We've always seen being open through interoperability with various platforms around the world as being advantageous, not just for us, but for you, our clients as well. Anyway, we're delighted to be here today at this webinar to discuss this interoperability connection between the virtual environment and MagiCAD. Okay, so I think we need to meet the presenters now. So my name's Neil Gibson. I'm a business development manager here at IES. As many of you will know, IES are world leaders in building performance simulation. Our technologies provide analysis from the very earliest stages in design through construction, commissioning, and into operation. And that's for single buildings, into multiple buildings, and up to city level. I'm joined here today by Rob Harmer from MagiCAD. Rob, do you want to introduce yourself and say a few words?
Yeah, hello, thanks Neil. I'm Rob Harmer. I'm a technical manager at MagiCAD here in the UK and Ireland. If you're not familiar with MagiCAD, it's in a quick sentence, it's a software within a software, the software being Revit or AutoCAD. In this market, mostly 99% is MagiCAD for Revit. I've been a technical manager here for 5 years, helping to roll out MagiCAD for Revit in this market area. It's going pretty well. So I'm also very pleased to be here with Neil and the team at IES to hopefully move things forward with more interoperability and explain the M&E and building physics workflow all the way through using at least these tools. Thank you.
Great. Yeah, great, Rob. Thanks. And it's good to have you here with us today as well. Great. Just before we get started, I just want to reiterate about the questions. If you have any questions at any time, if you can just type them up in the question pane and we'll collect them at the end. But we'll crack on with the presentation now. I'd like to explain a little about why today's webinar is important. over the past few years, the way that we engineers within our construction industry approach design and the tools that we use, they've changed and changed quite dramatically. For example, one of the biggest changes was in the late noughties. Was through on the back of the recession, there was a drive for efficiency, and this really promoted the use of what became known as BIM. And that really was all about wrapping up digital transformation and moving forward. So there was a move from, for example, in a very simple term, moving from 2D information into 3D. And of course, there's lots of other layers onto that. And we talk about 4D and 5D in terms of deliverables from that. Big changes, though, through productivity. We are being asked for by clients, for example, to do more work within our projects, more detail. And of course, we're always being asked to do more projects. So productivity is a key thing as well. Another big change has been the understanding and the education of our clients. So clients are now being ever more prescriptive within tenders and asking for information to be presented in a particular way and in particular detail. And if we think now, for example, demands on the project, so net zero carbon, for example, we have to prove that we're reaching those targets. Costs have to be detailed. Everything needs to be highly visual. So there's a big drive to move from hand calculations and spreadsheets into more modern techniques. And of course, for some, it's just leaning more towards the marketing value of digital transformation and being seen to be embracing it. If we look beyond our own industry, almost all other engineering-based sectors that I can think of, so for example, F1, marine, aerospace, they've been using integrated design for decades. We in the construction industry, we're really just catching up. Interestingly, and a bit of a fun fact for you, but there are many different digital platforms to choose from. The McKinsey report in front of you, which is an interesting read if you get the time, it tallies over 2,300 separate digital platforms in construction. That's over 2,300 digital platforms. So, picking the right platforms for your business isn't easy, right? And then making sure that they work together is going to be even more challenging. Like today, we're going to show you our solution, simply really boiling down to two key tools, the virtual environment and MagiCAD, and we hope this helps you. Okay, so just want to talk about and reflect on really yourself, maybe within your engineering practice, consultancy, business. And if we think about the type of software platforms that you need to be able to do your day-to-day job, and really these boil down to three core types of software platforms. The first one is an analysis tool, so like the virtual environment. So you need a tool to be able to do all the crunching of the numbers. So you need to be able to understand the building performance of the building in question in the project, and understand, are you, be able to validate its performance? So again, if you're looking at energy or carbon or overheating, are you meeting those requirements? Are you meeting those goals of the project? Are you able to verify against compliance? So if we think about Part L or Section 6, thinking about GLA London Plan, you need to be able to make sure that you're, meeting those requirements as well in the project. So you need something to crunch the numbers, and that's the virtual environment. Next, once you've done that, you need to be able to turn that data into a design. And that's what you'll use MagiCAD for. MagiCAD will take that data and execute that design, literally developing that design for heating, cooling, and ventilation, literally creating your ductwork and pipework to be able to communicate for construction. There is a third consideration, And that's what we term the common modeling environment. Okay, so what do we mean here? So typically this will be set by the architect. In the UK, this is definitely the Revit platform, and it's essential that you're able to communicate directly with the architect. And what we mean by that, not just in verbally or in person, we mean digitally as well. So being able to perform your analysis and create your design and then communicate that within the common modeling environment is going to make everything so much more easily for you. So that's why today we're pleased to say that, look, not only will these three platforms deliver the majority of your requirements as an engineering business, but that they work together. And the cool thing is they will form the ecosystem for you and your projects. Okay, just to reiterate what we're going to be looking today. So today, in our demonstration, you're going to be looking at a Revit model being imported into the virtual environment. Once in there, we're going to do some analysis. In this case today, it's going to be our SIDSI loads. Once that's done, we'll then be able to export through our new interoperability connection to MagiCAD. There, MagiCAD will then take that data and then develop using their tools for heating, cooling, and your ventilation design in there. Now, it's worth mentioning at this point that we're very specifically looking at the workflow of this, and both platforms, IESVE Virtual Environments and MagiCAD, have a vast amount of capability to each of their platforms, far more than we're able to do justice really today. But I know that if you have any questions or if you want to know more about either tool, please feel free to contact myself or Rob, and we're happy to do that. And who knows, maybe Rob and I will do another webinar in a few weeks' time and show a bit more insight into that. But today, we're going to be sticking really just to the loads itself. But just so you know, the virtual environment can do a whole vast range of analysis on your project. I'm sure you already know this, but not just your loads, but you could be looking at, for example, compliance with Part L, Section 6, looking at LEED and BREEAM, HVAC design, airflow, CFD, lighting, daylighting, solar shading, energy and carbon, a whole vast array of analysis in there for your building. MagiCAD itself, they've got, for example, the electrical side, so the cable sizing, sprinkler design, and much more as well. So there's a lot there to talk about, but not today, another time maybe. Okay, yep, so just before the demonstration, I actually would like to ask you a couple of questions. So I'd like you to help me out and pick the right answer for you. So bear with me, so I'll set up the first question. Okay, so the first question I'd like you to answer is, which software do you currently use for your load calculations? So which software do you currently use for your load calculations? And if you can pick the one that best suits you, that'd be great. If that choice is not available, or if you can't see the closest one to you, then don't worry, and we'll see what's been asked there. So just let that run. So we've got 5 choices. We've got the virtual environment, TAS, Design Builder, Comp, and lastly, hand calculations, Excel spreadsheets. Okay, I'm going to close that off now. There we go. Thank you. Now I've got the second and last question. I'm just going to launch this just now. So this is the second and last question. So which software do you use currently for pipework and ductwork design for your MEP design? So how do you do that? So what software do you use for your pipe and duct design? We've got 5 questions there, or 5 answers rather. So we've got MagiCAD, Comp, SciMap. You maybe still use your Duculator, and other. So just let that run. Okay, and I think we'll stop there. Okay, well, what I can do is, and if I can do this correctly, I can share the results with you. So question 1, if I can share this with you. Yeah, so which software do you use for your load calculations? And yeah, interesting results there. I'm good to see a lot of you using the virtual environment. I like that. Maybe get you some more. But actually, quite a lot of you doing hand calculations, Excel as well. That's interesting. Okay, and I'll do the. Let's see what the results were for the second one for your design software. And yeah, interesting. So again, digitally MagiCAD there coming out top, which is good. We like to see that as well. But still, a lot of you doing using your Ductulator and other there as well. That's interesting. Good. Thanks very much for that. So what we'll do is I'll put that away. Okay, so let's get on with the demonstration. So I'm just going to load up. I've got a video here that I'm going to talk through with you. And hopefully you can see the screen there. You can see that we're within the Revit environment. We've got a model there. That model is actually the IESVE head office up here in Glasgow. And we're just looking at some of the performance data associated with that model there. And so we're just going into the people in the room. We've set that to 7. And we've done that deliberately, so just keep that in the back of your mind. And what we're going to do now is export that model as a GBXML, ready for importing into the virtual environment. So we're going to create that GBXML and save that somewhere that I can find it in a couple of seconds. Okay, now that that's happened, I'm going to launch the virtual environment. You can see here we're at the landing page, and I'm going into new project. Handily, there's a link to be able to bring in my BIM file. There you go, I can find my GBXML, and I can choose whether I'm just bringing in the geometry or I'm bringing in other associated data. So I'm doing that as well. I'm bringing in geometry and data, and I'm loading that GBXML into the virtual environment. Okay, so that's happening just now. Once that's done, I get notified that that's the case, and it's in there. I'm just going to save the project there within the virtual environment. And I'm just looking at the model just now, making sure that that's come in well, and it has. You can look at it in 3D. Good. So opening up Apache, I can now check to see that the data is correct. So you can see there that in that room, 7 people, that's come across well, which is good. And I'm now able to do my simulation. So using SIBC loads within the virtual environment, I'm able to do my loads calculation. Now that's not taken long at all, and I've now been told that that's in what we call Vista Pro. Vista Pro is our analysis window, and of course, I'd be able to interrogate the results from that calculation within Vista Pro. But for those that use the virtual environment regularly, you'll notice that there's this new button at the top there that's available when doing my SIBC loads. Now, if I'd chose to use the ASHRAE methodology, that also would have appeared. And this is a new functionality that has come through on V 2019 Feature Pack 3. So if you haven't got it, it's worth making sure you're on the latest version. I'm just going to get the video going again. And what that does, it then allows me to then generate my reports. And that's now been generated and in my content manager. And now you can see my load report. Now this particular report is in Excel format. And you can see here, this is the results from that. And now there's 2 things to mention here. One, this is key to being able to export your data to MagiCAD. But 2, the worksheet that you're seeing here is editable, and that actually allows you to gain a lot of value from it. So for example, at the top here, you can see, for example, your load safety factors. You're able to edit that. So it defaults at 10%, but you could make it 15%, for example, and that will then update your results in here. So it becomes quite a valuable worksheet to have anyway. But sticking with point one, it's the key thing here is you're able to then use this to connect to MagiCAD. So what I'm going to do now is I'm going to pass over to Rob, and Rob will be able to take you on to the next stage. So Rob, I'm just going to find the button to give you control of the mouse. And there you go, great.
Okay, thanks a lot, Neil. Yeah, so I'm just going to take on the remainder of the demonstration from here. After IES has spat out the results into a spreadsheet such as this. Obviously, it's a familiar Excel type spreadsheet that we've all seen before. And I'll just press play here. And you can see here the results on the screen. And the ones we're particularly concentrating on are the heating load and the cooling load at the moment. They're the two main values that we're going to look at in here. And you can see in Revit itself, you can see each of those spaces that's been set up. There is 0 and 0, so valueless. You can see in the schedule as well, in the space schedule, there's value is 0, so there's nothing in here at the moment. These could be populated by Revit's own calculation engines, but they're not really UK or workable at the moment, so that's why the IES importing into Revit is extremely important. Then we use MagiCAD's spreadsheet export tool. This will generate a spreadsheet based on anything really in the model, but in this case we're going to look at spaces, and this is going to export whichever parameters you wish, which in this case I want to export the design heating and cooling loads. But of course they're all going to turn out as blank, as 0 in the spreadsheet, obviously, because that's the same value as what's in the project right now. But what we're going to do is populate those values and push them back in. So I'm just using this tool now just to create the columns in my spreadsheet, which will ultimately be exported shortly. And once I've exported that spreadsheet, I will then change the sorting order of the spaces to match exactly as per the IES spreadsheet. So a little bit of data manipulation in Excel to have those matching. But every space name and number should be the same because you've used the same model to import it into IES and back out again. So there should be no mismatching of names, numbers, or anything like that. So it's quite an easy operation. So just using basic Excel, I'm just going to put into a sort order. Also helps for a bit of checking as well. Put into sorting, you could just do it and hope for the best, but I think it's best to do it in a logical order that you can double check and make sure that's sorted in that order there. So back into the IES spreadsheet, we can look into here, into this one, and then have a look at the peak sensible cooling, and literally just copy and paste those in. Obviously checking as well that your units are matching. You don't want to have kilowatts and watts overlapping there at all, because that would be a bit of a disaster in the design side. So make sure the units are identical. And there we go, it's just pasted straight in. And this is just imported back into the model in a similar fashion, just the reverse of before really. You get a chance to review your values before that gets imported in, so you can see, make sure that the right values are coming in the right way. You get a bit of an overview there. If you're happy with it, you just press accept changes and then it will populate all that data. So now you can see that all my heating and cooling loads are imported. Where I haven't got cooling, it's on 0 because it may be uncooled, or it's unheated spaces will be on 0 for heating as well. And you can see in the space schedule that they're all updated in there correspondingly as well. So that's just getting the data into Revit. That's quite straightforward. But then how do we use that data to then take the design forward and actually complete a mechanical design? So I can reference all these different space data. You see, I can see them on the screen here. I got a schedule, however I want to do that. And then using MagiCAD's installed product, this is a unique feature of MagiCAD that you can say put a radiator in, choose your system temperatures, and it will actually start calculating your delta T's of both the flow and return, so in this case 80-60, and also the delta T of the radiator into the space. So say 21 degrees, so that's a delta T of say, I don't know, 50, 49, something like that. And it allows you to choose your radiators based on the characteristics and performance you wish and get the correct sizes. And then that can all be then double checked and tallied against the space data that you're importing those devices into. So I'm just going to import that in now. Just add some valves on here just for completeness. There's my lock shield there. And once I'm happy with that, I can just drop that straight into the project. Another little feature here, you can also choose your top, bottom, opposite end type arrangement as well on the radiators. Then just drop it in there, and then that's the process just from literally a heating only radiator point of view. That's quite straightforward. Then we can use other tools in MagiCAD. Those who've seen it before, I'm sure are familiar. We can use piping connection tools and things like this to help speed up the actual process. It can be very, very clunky just using basic Revit tools. I'm sure people have experienced. So having tools like this can really help speed up and develop the design a lot quicker, especially for stage 4A for consultants who are doing a well-coordinated model, but also the design calculations is a kind of perfect design stage really for that. So you can see now adding there's a little tag onto that radiator just for my own reference, and I can see that I'm going to have a power or heating duty on that radiator of 560, and that matches my my load of my room as desired. You can add margins on as well. You can add them in the spreadsheet, of course, before you load them in. You can add margins on as you add the power into the radiators. It's perfectly up to you if you want to put design margins on. You can add it at whichever stage you wish. Now I was going to add some chill beams. This is a combination of heating and cooling and ventilation all in one unit. MagiCAD does support this in Revit very, very, very well. So you can see the connectivity of the heating and cooling using the delta T's there of 80, 60, 12 and 6 on the chilled. And then and you can see the live dynamic data there for this unit for the flow rate and pressure drop and the ventilation flow rate and pressure drop and sound data as well. And there's my chilled beam. So I'm just going to drop that into the project. And I can then just spin it around and then just connect it in again using some of the connection tools that we've got just to ensure that connects in there properly. This one has a heating and cooling, as you know, and vent. So each of the tools will have a role to play here. So the heating and cooling, here's the chilled being connected. So you can pick that separately from the heating. It knows which one is assigned to which. And you just use that connection dialog box to help you create that correct connection to that unit. And then we can do that again for the heating now. So it's a very, very quick operation to do all this. It's just a lot slicker than Revit out the box, how that works. And a very important thing, having these sort of distinctions in all the systems and be able to connect like multiple systems to one unit without any system mismatch is something that's quite challenging in out of the box Revit as well. So there we go. There's my chill beam with my fresh air coming into it and the heat and chilled connection as well. Of course, you can check the data anytime you want. The product data is in there on any of the devices. You can jump in there and check vent, heating, chill water, performance, and when you recalculate, you can go and recheck it as well. So it's almost like live dynamic data in each of these products that you can see. You'll notice here that I've got a lot of like pipe and duct, a lot of tags everywhere showing my or what should be showing my flow and pressure data. It's not yet. It's blank apart from the sizes. So we need to run some calculations. So as you can see here, this is a MagiCAD sizing calculation. So it's a huge enhancement over the standard Revit one. You can then calculate entire systems at once, networks, just branches, however you want to do it, and set sizing rules and criteria of different sections, all automatic, where Revit out the box is just basically a manual operation. You've got to select the ductwork and give it a size and a pressure drop per meter and do it manually. Obviously, it's really difficult to manage change and things like that with a tool like that. And you can see here it gives you an instant calculation report summary. Direct in the model, it's bi-directional. You can click in the model, click in the report, and it will send you to that exact location or that place in the report, and you can see exactly what's going on. And you can see the also like the sizes, old size and new size, and those columns there is going to give you a preview of the size it's going to calculate, along with obviously the flow data like velocity and pressure drop per meter that's within that criteria. And press OK, and off it goes, calculating all the selected network in line with that criteria. So you should see some of the piping change in size. As we do that, you can see there, it was all modeled in the same size before. Now it's reduced where it can do, and you can see that on that system, all the tags start being populated with the data as it's calculated. So really, really informative, completely interrogatable, and very, very easy to interrogate. Revit out the box, the calculation, even if it did have SIBSI, which it doesn't as a standard, and if it did work, you still have to use the report that it spits out, which is a HTML file external to Revit, which is an absolute nightmare trying to find your way back into Revit with that. But with this, you've got this bi-directional report in Revit Live, which helps you just jump around the project and look at anything you want in particular. So I hope you can see that design being built up now. This is just obviously the sizing of the pipe work. I'm just finishing that off now. I've done the VT, the CT, and the chilled in terms of sizing now. And you can see those tags being populated at the same time as well as we progress through this design stage. Ventilation now works in a similar way to the piping. We can just calculate that. Again, there's the calculation report. We can calculate that sizing based on a set of rules, and I said before, you can calculate the based on a set of rules at any part of the system. So if you had like a noise sensitive area, or we wanted to have all branches above ceiling voids and corridors at 4 meters a second and risers at 7, then you can assign that across the board, and it'll calculate based on that criteria for you. So I'm just going to do a bit of a 3D overview now of the services, so you can see it and appreciate what's actually happening on this particular floor of this building. So you can see we've got all the fan core units, well, chill beams, probably a more accurate way of saying it, and the radiators, the VT, CT, and the chilled and the duct systems all there connected together like that. And that is really important. That's going to form the basis of our design. So it's pretty much going to design as coordinated. So there's no transferring this into another package and then designing outside in a separate package and then importing data back in and then exporting back out and then doing some design, importing back in, deleting some stuff that you've drawn before, remodeling it, hoping the calcs are still the same. It's all entirely within Revit. So you've got one environment. Whatever you model, the design is based on that. Wherever you change, the design is then changed to suit. So that's the real benefit of having a system such as this. It's worth mentioning as well, I think, if you're not familiar with Revit, the reason MagiCAD brings all this to the table is the fact that Revit is an American product, and if you ever try and use it for design, you're faced with ASHRAE and international plumbing guides and stuff we just don't use in the UK. MagiCAD comes with, as you'll see here, SIBSI Guide C, pressure calculations. You can interrogate literally any bend, fitting, anything, and see what the K factor is from the SIBSI Guide C. We've programmed the entire SIBSI Guide C for K factors or zeta factors into the software. And we also have, on top of this as well, it's not related to IES, I suppose, in terms of loads, but we also have domestics. So we've got the plumbing for domestics, for loading units, all the BSs supporting the calculations, IOP, and drainage calculations as well on top of that. But you can see, now we're pretty much getting to the end of the design for the duct and pipe systems for the pressure calculations as well. So you can start sizing fans and balancing the system if you want to do that. Put VCDs in there, see what the balancing is like across the system. So it's very, very comprehensive in terms of a design package here. So it's just a pressure drop report for the piping system there. There's the chill water, and you can see it's got a summary there of flow and pressure. There's your pump size basically straight away there. Okay, that's another pressure drop calculation, and that's pretty much going to be everything we're going to show today. There's a hell of a lot more to MagiCAD in Revit. This is just the design and calculation element. There is a complete host of modeling tools, a whole library of online library of equipment. You saw a little taster of that as well. And there's also loads of other handy tools as well, like builders work creation and things. So it's not just limited to a calculation package. So it's just one part of it. It's like almost like a complete design and coordination and product content package, if you like, for Revit. And one thing that I'm really keen on, especially my history I've been a mechanical engineer in building services nearly 20 years, so I've done my fair share of designs and checking of designs, and QA is obviously hugely important, and Revit as a constantly evolving model with like 10 people piling into the model is a very difficult thing to control. And if you issue in a tender, you might want to know exactly what was calculated at a certain time, or a contract issue, or whatever you're doing. So having tools like this where you do design in Revit, and then you can do like color coding of duct velocities, you can do pressures, you can do whatever you want really, and you can see instantly and visually exactly what's happening. And I've checked designs in my past. I never had anything this obvious for checking. Normally checking Excel spreadsheets or printed out reports from HeaverComp or something, and it's really hard to relate that to actually what's on a drawing. With this, the drawing effectively is the calculation. And then you can just print that off to a report, and you can store all this in your QA file. So your whole design is time-stamped there. It's got a time and date when that was created, and a summary of that calculation that we saved in your QA file, and say this is tender issue. So you've got an exact record of what was produced when, exactly at that time, so you can always refer back to it and know why you chose that pump or that air handling unit or whatever it was before someone went in the model and changed it. So that's it really. Thanks a lot for sitting in and listening to that. I know it was quite a quick run through, but if you want any more information, then some details are at the end to get back in touch with us. So thanks very much. I'll hand you back over to Neil now.
Yeah, hi Rob. Great. Thanks Rob, that was excellent. Really cool to see that in action and to see, the end result. So being able to see that golden thread of information, if you like, all the way through the design process. I'm just going to lose this video. Hopefully we're back to the presentation. Good. Yeah, excellent. So just to summarize where we are, I've got a couple of slides left before we go into the Q&A side. But in summary, what we're presenting here is a robust engineering ecosystem. Okay, between the three core software platforms that we saw there, you're going to be able to do what it is that you need to do as an engineering design team for your projects. And so, we've just proven there with the Helix building, from the architectural model all the way through the virtual environment, doing your analysis, and then into MagiCAD to execute your design, ready to be passed on. Yeah, really cool. A word that I've used a couple of times this webinar, productivity. So I know, and actually it's interesting looking at the polls that we did. Obviously, I understand it's quite a lot of you still using Excel and hand calculations for developing your design, and I guess a lot of you will be saying, well, this is a bit of a step up from where we are just now, and there's no getting away from that. That is the case. But through what is a small learning curve, there are some big wins to be had. And the big one really is about productivity. And Rob talked about that a few times through his demo, particularly, and one of the big ones there was about the QA side, making sure what's in there is working and going forward. But the productivity side is key. You know, being able to make sure you're by moving up to that level, you're making the most efficient use of your time. You're able to put in far more detail than you might do otherwise. And of course, you're going to be able to do more projects as well. So productivity is a key one there. Okay, just on a slightly different note is that, look, you've probably already got the virtual environment. If you're an engineering contractor or a consultant, you've probably already got the virtual environment somewhere in the office, whether somebody that champions it or there's a team that use that. And that's fine. But of course, as your mechanical design team, there is nothing stopping you from using the VE yourself. You can, you don't need to have the full package. I always do like it when everybody gets the full package, but you don't need the full package. Just a couple of key modules there from the virtual environment, you know, starting from just a few £100 would get you the ability to analyze your projects like we saw today, even just for loads, and incorporating that in there. And that at least gets you up from doing those hand calculations, for example. And of course, though, if you want, you can do much more than that. Another big key point from today is why would you do this? And it is again going back to the tools that we use. So again, if you're using spreadsheets, hand calculations, you will be just following the IESVE Guide methodology. Okay, but there's a reason why people are using these digital tools, and one of the key reasons is around accuracy around the calculations. So for example, by moving to a 3D geometric environment like IESVE Virtual Environments in MagiCAD, you're going to be able to take account of the architectural model. Okay, whereas your spreadsheet, it's just a floor area. It's a number you're putting in. So you're losing a sense of the building in that way. And then you can start layering other analysis on top of that. So things like solar shading, okay, things like air movement. So there comes a point where you say, well, accuracy, accuracy is beating what you've got away with to this point. So if you're still doing that, there'll be a point where you're going to have to change and move up, and there's big wins to be had, and accuracy is one of them. Okay, and on the back of that, I know the virtual here at IES and at MagiCAD, we have dedicated training teams who are there, friendly guys who are happy to help you, train you, project mentor you, support you in that process. And I think you'll be pleasantly surprised that actually, while it might look like a bit of a step up, it's not really, the learning curve isn't really that steep. So we're happy to do that. Okay, just a wee side note, I'm just going to take this as a wee IS side. There's been an update so while we talk about BIM interoperability, there's actually just been an update to the technical guide for Revit interoperability. And you can see it's already been uploaded into our help section on our website. So you can use that link to get there. I hope today you've enjoyed today's webinar. From the IES perspective, we've been doing a number of free sessions over the last few months, and including lunch and learns and upskilling sessions. All of these sessions are recorded and stored online, and they're free to access. And you can see the link down there, the web link down there to the lunch and learns. And I've specifically highlighted the sessions there, the 3 sessions there, as natural follow-on sessions from today's webinar. So of course, come to us, speak to us. We're happy, both Rob and I, happy to talk about anything to do with the virtual environment and MagiCAD and show how this works in more detail if you want, or specifically. But in terms of this direction of travel, I think these would be of interest to you as well. Okay, and Rob, that's us in terms of we've arrived at the Q&A session. So it's let's have a look at the questions that we've got. Okay, so there's a couple of questions about the Revit import into the virtual environment. The best thing there is, obviously we've shown that was maybe asked before we had the technical guidance, but yes, there's what we showed there was a simple translation of that geometry, but there is a process to make sure your Revit model is correct, and that will certainly help with the success of importing that. The technical guide's there for that, and happy to definitely refer to that when doing it. There was a question about the SIBSE loads calculation in the video. Was that real time or sped up? That was real time actually, but again, we were just showing that process. It can be as quick as that if you like, but often you would be looking at there's other steps within there in the background that we didn't go into today purely on a time basis. So you would be wanting to check, for example, your construction setup, the profiles you're using, that sort of thing. Yeah, good. Okay, quite a few of you saying that you're currently using HEVA-Comp and you're wondering how much of a difference to use the virtual environment in MagiCAD. So again, I think I sort of covered that. Maybe that was asked just before, but yes, training. There's always going to be training involved, but I don't think it's as much as you or as challenging as you might first think. But we deliver training all the time, and we're happy to do that. So I'm sure we'll be able to cover that. Okay, Rob. There's one for you, MagiCAD. So you used a MagiCAD product selector to assign the loads. Is there an option to use a node instead? And how complete is a selector library?
Yeah, the node is actually a very good question, because we actually have this function called a connection node, and it can live, it sits on the end of ducts and pipes. Its behavior will change depending on what sort of system it is. So it could be a domestic system, heating, chilled, vent system, and it will have different behaviors, whether it's loading units or heat load or flow or whatever. And yeah, the nodes can be used instead of the final connections, and they're generally used, say, in early stage design. We don't want to draw or model every last nut and bolt all the way down to the final device. So you would actually just have a node that represents the downstream connections from there. Huge time saver at early stages where you don't want that level of detail. We want the actual calculations at that point. And also they can be used whether for something like has an open end, like you've got an open duct blowing into a plenum or something like that. You might have a node on the end of there as well. So, or it might be that you've got future phases. So phase 2, and they have this node on the end as well. So all these things are kind of limited in Revit, as I said before. It's very tricky to manage, like future phases and open ends, things like that. So yeah, it's really useful. So yeah, good question, and we do have that. And in terms of I think it's referring to the library when it's a selector. I'm not totally sure, but it's a very extensive library. Obviously, you can't guarantee that every manufacturer ever one is in there. Definitely not. But it's very extensive, and we also have a MagiCAD Create software. You can create your own content from very, very easily as well. I won't go into that in too much detail now. It'll take a lot of time, but there are lots of ways of developing and finding or creating content to your requirements using MagiCAD tools.
Great, thanks, Rob. So there's quite a few questions here really for you on MagiCAD. So the next one is, okay, is the product data part of MagiCAD, or does this need to be installed from other sources?
No, that what you saw there, like the product data, that's just embedded in the actual the products themselves. So the way it works, you download a product from the MagiCAD library. Feel free to have a look on there. If you go to MagiCAD Cloud, just literally on an internet browser, you can just have a go through. You can see the whole library basically, so you have a look through and see what you think. But when you download something from that library, the embedded data comes down with it. So if it's obviously different. If it's a radiator, it might have a delta T of the heat output from the radiator to the room. If it's a fan core unit, it might have heating and cooling with flow rates and pressure drops through the coil in the unit. So there's loads of different aspects of that dynamic data, but it comes with it. Yes, it's not a separate package. It just automatically comes with any product that you download from the MagiCAD cloud with MagiCAD.
Okay. Once calculations are done, system sized, how adaptable is MagiCAD to design changes?
Well, that's a really good question as well, because that's one of the, I think I alluded to it in the presentation there. That's one of the main reasons why it's so much of a time saver, because what, in my experience, is I've been in the industry quite a long time, and my experience, what really killed me on projects was design changes taking place, and you finish your design, you've got everything sized up, you've got all your runs, everything, you've got your schematics drawn out with all the detail, and the next thing you know, someone changes a library to a swimming pool or something. It's exaggeration, but things change. Change a classroom into a meeting room, or it turns into a kitchen or something, and everything's got to change. And the beauty of having the live design data in the model is that when you make those changes to suit the new architectural layouts or client requirements or whatever you're changing it for, you just redesign it in Revit with MagiCAD and Revit, and then you just hit update in terms of the design, just recalculate it, and everything's instantly recalculated. So the design changes are really, really quick. And that's the one thing that really, you'll notice a big increase in efficiency of that. It's not just the efficiency of doing the design from A to B, it's also all the changes that take place along that route. And that's why if you have an external third-party software outside of Revit that you're constantly importing and exporting to, that doesn't mean IES, I'm not talking about that. I mean, like a design calculation for MEP, something like HeaverComp, I've used it myself in the past. Then you have to obviously have a separate design package or an Excel sheet separately, and then constantly try and match that up with what's being drawn and modeled in Revit. But with this tool, it's obviously the design is the model. So big savings on changes there.
Yeah, thanks, Rob. Just another question here about the Revit, if there's any guidance, but I think that might again have predated we've had the updated technical guidance. That's from James, so you can certainly download that from the IES website. And James was asking specifically in terms of Revit guidance and setting up the Revit model correctly for importing into the virtual environment. Is there anywhere that you can point architects to reading that update to the technical guidance on interoperability with Revit and IES would be that document, and that would be something to then forward to the respective architects on there. Of course, we also have training and support, some of it free, some of it paid for, where we can support you in that on projects. Another question here from Nick, does it work with Revit LT? So I guess is that you, maybe?
Yeah, I think I know Revit LT. I'm pretty sure it's not. You need the full version. LT stands for learning technology, and it's generally used for like students, things like that. So I could be wrong about that, but I have never seen it operating on Revit LT, if I'm honest.
Okay, from Jordan, he's asking, in terms of for the interoperability, is there a certain license type or module, for example, that's required? No, that's not the case. It's through a function within the latest version of the virtual environment, and basically enabling you to, with those loads reports, and then specifically that Excel load report. That's the key part there that you're able to then import into MagiCAD. So as long as you've got the virtual environment, you're going to be able to, and you're able to generate those results. You'll be able to. That's included there. For you, Rob, is the import-export data, is that an additional cost to MagiCAD, or?
No. The tool I used is the MagiCAD Spreadsheet import-export tool, which sort of demonstrated there, and that's included with MagiCAD. So I mentioned in the demo, MagiCAD is is a software within a software, and what was shown today is just a section of it, a portion of it, which is just the design calculations, but there's also a whole raft of other sort of apps and tools, if you like to put it like that, and one of them is the Spreadsheet Import and Export, which comes with any purchase of any module. And I think I've just been looking through the questions, so I just want to extend that answer into answer another question where I think people are writing about how MagiCAD breaks down and modules and things like that. We won't people ask about costs, but we won't talk about costs in this session, unfortunately. The best to contact our sales team on the details are on the screen now. But in terms of modules, I can certainly explain. This event, pipe, electrical, and schematics are the main modules, and they're purchased individually. And each of them will also come with the common tools, which I've explained is like builder's work or that spreadsheet export, etc. So it is a modular solution. So if you only want, if you're mechanical, I don't know, mechanical designer, then you could just get vent and pipe if you wanted. So it is broken down like that. You can have any combination of each. You can have 2, 1, 7. You know, doesn't matter. You can purchase it like that. So I hope that answers that other question I got along those lines as well.
Yeah, no, thanks, Rob. Well, that's us actually over time now. That's we're past just about coming up for 2:05. There's various questions in there. What we'll do is we'll form a FAQ and respond to those. Happy to do that. But I guess that's time up. So I'd just like to say thank you to everybody that's attended today and for your time. Also, Rob and your team at MagiCAD, just want to say thank you very much for co-hosting today, your efforts with that, and the efforts really over the last few months. It's been really good working with you. All right. Have a good one, everyone. Thanks again. Thank you.
Thank you.